Welcome to Java Space. So, in this video, we are going to look at declarative transactions, where we use AOP to demarcate a transaction or to mark a method execution as a transaction. Or you can also say where you want to specify transaction demarcation, so that then the framework would be able to manage that execution for you and manage it for you as a transaction. So we mentioned, and I will always mention, that transaction is a cross-cutting concern. It is it cuts across multiple places in your application, and you want to modularize it. So if you put a transactional annotation either on top of a class or a method, you are marking that as a transactional demarcated area, which means the framework will then at runtime create proxies, add some code to initiate a transaction demarcation, and also add some code to end a transaction demarcation. So this is AOP. So what happens is that where you have added a transactional annotation, Spring will create a proxy. Let's say you have put this in a class, and that class implements at least one interface. Spring will create a JDK dynamic proxy for you. Then the calls to that method that has been annotated with this annotation, if it's put in on top of a class, it means all methods in that class have this annotation. So now, or you can put it on one method if you don't want to have every method have this annotation. So now the call to a method that is annotated with a transactional annotation, that is annotated either directly or implicitly, indirectly. So the call to that method will go first to a proxy, because now Spring is in control. Then the proxy object, which now will wrap around that functionality. So the proxy will then inject some transactional behavior inside that particular execution. And then it will delegate it will begin a transaction, then delegate a call to the target method. When the method is completed, the call will go back and the proxy will end the transaction and then return the call to whoever was calling. So you see that the target method in this case is called from a proxy object, and the proxy object wraps a service which you want to call, which is the target object, then add some additional logic to manage a transaction. So this is done with AOP, and you use an advice called around advice. Why? Because we want to control when we enter, or we can say we are interested in when you enter the method and when you enter the method. And this is how it works. So the call comes to a proxy delegates to an around advice, which is that code that has been created. On the around advice, you make a call to the target method. And then inside this around advice, this is where you're going to begin a transaction. Obviously, you will get a connection, begin a transaction. then execute the target method. When it's done, the target will return the callback to the around advice. The around advice will then close the transaction that it began. By closing, I mean it will commit it or it will roll back, depending on the outcome of the execution of the target method. Then it will go back to the proxy. Then the proxy will return to the method call. So this is the diagram, the way it works. Well, in this case, I'm explaining it in the context of a Spring and telling all the aspects or all the parts that needs to be touched. So we see that we are transferring money. The call does not come to the target service directly, no. The call comes to a proxy, then that call is intercepted with a transaction interceptor. The transaction interceptor delegates to a transaction manager, which can then be data source, as you saw, transaction manager, JPA transaction manager, Hibernate transaction manager, JTA, WebLogic, WebSphere, any of them. Then the the transaction manager will then determine what to do. Okay, I need to begin a transaction. It will begin a transaction. Then, after it has begun a transaction, the call will go to a target method, or you can say target service if you want. When the service is done, as I have shown you here, I was explaining, it will return back to the transaction intercept. The transaction interceptor then delegates to the transaction manager. The transaction manager will then decide, is it a commit or is it a rollback? If it's it will commit the transaction. So if it's a rollback, the default behavior of rollback is if no custom rules are configured in the transactional annotation, the transaction will roll back on runtime exception or an error. Let's say you are the target service method executed and it threw a runtime exception or one of its subclasses. Then the transaction manager will roll back the transaction. If it is an error, it will also roll back. But if it is a checked exception, nothing will happen. However, Spring does allow you to override this default behavior. So we will see as we proceed with the series how it allows you to override this default behavior.